Good morning. This is my course project for Data Communications and Networking 4. I have chosen these topics for this project, which are the wireless LANs, the single area OSPF, and the multi-area OSPF. Let's discuss the WLANs. A wireless LAN or WLAN is a wireless local area network that uses radio waves as its carriers. The last link with the users is a wireless to give a network connection to all users in a building or campus. The backbone network usually uses cables. This is the common topologies of wireless LAN that connects to a wired LAN. There is a need on access point that bridges wireless LAN traffic into the wired LAN. The access point can also act as a repeater for wireless nodes, effectively doubling the maximum possible distance between the nodes. What are the benefits of WLANs? Modern WLANs offer many benefits to networking, such as the mobility, scalability, flexibility, short and long-term cost savings, the installation in harsh environments, and reduced installation time. Let's discuss about the IEEE 802.11 architecture. It defines as the physical, logical, and media access control layers for a wireless local area network. The 802.11 networks can work as basic service set, it's called the BSS, and extended service set or the ESS. BSS can also be used in ad hoc networking. Let's discuss about BSS and ESS. In ESS, multi-access points connected by access points and distribution system as Ethernet. BSS partially overlapped. Physical disjoints BSS and physically collocated BSS in several antennas. Let's discuss about the wireless antennas. We have the omnidirectional Wi-Fi antenna. We have the directional Wi-Fi antennas and the Yagi antennas. Omnidirectional Wi-Fi antennas is factory Wi-Fi gear often uses basic dipole antennas, also referred to as the rubber duck, designed similar to those used in a walkie-talkie radios. It provides 360 degrees coverage. While directional Wi-Fi antennas, it focuses the radio in a given direction, which enhances the signal to and from the AP in the direction the antenna was pointing. While the Yagi antenna, it is a type of directional antenna that can be used for long-distance Wi-Fi networking. Now we discuss about the types of wireless attacks. In a wired network, packets of information are transferred along with the physical medium, such as copper cable or fiber optics. So in a wireless setup, the data is quite literally broadcast through the air around you. Furthermore, physical access is not required to gain access to a network. So cyber criminals have now new ways to wreak havoc on your network infrastructure. So let's discuss one by one. We have the packet sniffing. This is a technique whereby packet data flowing across the network is detected and observed. Network administrators use packet sniffing tools to monitor and validate network traffic, while hackers may use similar tools for nefarious purposes. Then we have the ROG access point. It is a wireless access point that has been installed on a network's wired infrastructure without the consent of the network's administrator or owner, thereby providing unauthorized wireless access to the network's wired infrastructure. Then we have the password theft. Password attacks are one of the most common forms of corporate and personal data breach. A password attack is simply when a hacker tries to steal your password. Then we have the man-in-the-middle attack, or the MITM. It is a general term for when a perpetrator positions himself in a conversation between a user and an application, either to eavesdrop or to impersonate one of the parties, making it appear as if a normal exchange of information is underway. The goal of an attack is to steal personal information such as login, credentials, account details, and credit card numbers. Targets are typically the users of financial applications like the e-commerce sites and other websites where logging in is required. Then we have the jamming. The jamming attack is one of the most serious threats to wireless sensor networks. By using the IEEE 802.15.14 standard. In such an attack, jammers who launch the attack can dramatically degrade the network performance by interfering with transmitting packets. Therefore, the study of the jamming attack and its countermeasures has become an important aspect of the WSN security. We also have the war driving. It's also called the access point mapping. It is the act of locating and possibly exploiting connections to wireless local area networks while driving around the city or elsewhere. Then we have the Bluetooth attacks. It is a type of attack in which the Bluetooth-enabled device hijacks another Bluetooth device to send spam advertising. Imagine you are in a public place with the Bluetooth on your device switch on. So like that. Then we also have the WPA attacks. Fake wireless access point is a type of hacking in which the hacker set up a wireless router with a convincingly legitimate name in a public spot where people might connect to it. Then we move to the second topic, which is the single area OSPF. Creates a neighbor relationship by exchanging hello packets. Propagates LSAs rather than routing tables updates. Floods LSAs to all OSPF routers in the area, not just directly connected routers. It uses the SPF algorithm to calculate the shortest path to each destination and places it in the routing table. Configuring single area OSPF. It defines OSPF as the IP routing protocol. So you have to type OSPF process ID. Then assigns networks to a specific area, OSPF area. So we have to network address wildcard dash mask area ID. Then in verifying the OSPF configuration, the command show IP protocols verifies that OSPF is configured. The show IP route, it displays all the routers learned by the router. These are the examples. When you put the command show IP route, you can see all these routers. Then in configuring OSPF plaintext password authentication, here we have to put the command IP OSPF authentication.key password. It assigns a password to use the neighboring routers. And the area ID authentication specifies the authentication type for an area. Now we discuss about OSPF in multi-access networks. We have the point-to-point, broadcast multi-access, non-broadcast multi-access, point-to-point, point-to-multipoint, and the virtual links. Now we discuss this one by one. What is point-to-point? Point-to-point is when two routers interconnected over a common link. No other routers on the link. This is often the configuration in one links. Then the broadcast multi-access, it is multiple routers interconnected over an Ethernet network. The non-broadcast multi-access is multiple routers interconnected in a network. It does not allow broadcasts such as the frame relay. And the point-to-multipoint, multiple routers interconnected in a hub and spoke topology over an BMA network, often used to connect branch sites to central sites. And the virtual links, it is a special OSPF network used to interconnect distant OSPF areas to be backbone area. OSPF authentication. OSPF supports the following types of authentication: null, no authentication, plain text or simple password authentication, MD5 authentication. The router generates and checks every OSPF packet. The router authenticates the source of each routing update packet that it receives. Configure a key password. Each participating neighbor must have the same key configured. Let's move to the third topic, which is the multi-area OSPF. Let's review the single area OSPF. Issues a large single area OSPF, large routing table, large link state database, frequent SPF algorithm calculations. To make OSPF more efficient and scalable, OSPF supports hierarchical routing using areas. Multi-area OSPF has a large OSPF area where it is divided into smaller areas, reduces processing and memory overhead, requires a hierarchical network design. The main area is the backbone area, area 0, and all other areas connected to it. So we have here the types of OSPF routers. We have the internal router, which is a router that has all of its interfaces in the same area. We have the backbone router, a router in the backbone area, which is set to area 0, the area border router that has interfaces attached to multi-areas. We have the autonomous system boundary router that has at least one interface attached to an external internetwork. A router can be classified as more than one router type. Implementing multi-area OSPFs. So we have 4 steps to implementing multi-area OSPF. First is the step 1, you have to gather the network requirements and parameters. And then the step 2, you have to define the OSPF parameters. Is it single area or multi-area OSPF? Then you have to know the IP address, OSPF areas, and the network topology. Step 3, configure the multi-area OSPF implementation based on the parameters. And number 4, verify the multi-area OSPF implementation. In configuring multi-area, there are no special commands to implement multi-area OSPF. A router becomes an ABR when it has 2 network statements in different areas. For example, R1 is an ABR because it has interfaces in area 1 and an interface in area 0. In verifying multi-area OSPVF2, these are the commands to verify the multi-area OSPF. Show IP OSPF neighbor, show IP OSPF, show IP OSPF interface, and so on and so forth. You have to note for the equivalent OSPF which commands simply substitute IPv6 for IP. In verifying general multi-area OSPBF settings, use the show IP protocols command to verify the OSPBF status. Lists routing protocols configured on router, number of areas, router ID, and networks included in the protocol. Use the show IP OSPF interface brief command to display OSPBF to related information for OSPF v2 enabled interfaces. List the OSPF v2 process ID, area that the interfaces are in, and interface cost. In verifying the multi-area, use the show IPv6 protocols command to verify OSPF v3. Use the show IPv6 interface brief to verify the OSPF v3 enabled interfaces and the area to which they belong. Use show IPv6 route OSPF to display the routing table, and use show IPv6 OSPF database to display the contents of the LSDB. So what are the advantages of multi-area OSPF? It has a smaller routing tables. means fewer routing table entries as network addresses can be summarized between area. It reduced link state update overload, and it reduced frequency of SPF calculations. So now I will show you some of the configurations for these topics. Oh, sorry. Now I will show you example for the single area SPF troubleshooting. So we need 4 routers. We need the 1841 router. Okay. The objective of this activity is using the different verifying commands for OSPF. So here you will see a lot of OSPF verifying commands. So we have to connect them. So sorry, I have to switch off, and we have to put here. I think this I have to delete, and just copy this. Okay, you have to rename this as router 1 R1. This one will be R2. This will be R3, and this will be R4. Now we have to connect them using the serial DCE. Okay, then from here serial 0. Okay. Now we have to assign the IP addresses on all the devices. So I have one table from the last lab. I will use the same table for the IP addresses. So for R1, I have it here. I will use the same IP address. So for R1, you have to, oh sorry, I didn't switch on. Everything must be switched on. Okay, go to configuration. S00. then R2, go to config, 800, and okay, then we go to R3, configuration for S0 serial 000 S162-2, then go to R4, 4000 as well. This is 32. Okay, so we are done. Now we go to R1, exit. We have to enable the OSPF routing with process 1 and areas 100 for the network 192.168.1.0. So from R1 we have to router OSPF 1, then network 192.168. area 100. We do the same on router 2. So router 2, let's, oh sorry, okay. Let's configure router 3. Okay. So now on router 4, we also have to enable the OSPF routing. So same thing we'll do. Router OSPF 1. Network. Now we try to ping R1 from R4. Let's see if there is a connection. R3. We have to switch on. Okay, so let's try to ping if from R1 to R4. Let's see. Ping R4 is 192.168.3.3. So we will see that it is a failure. Yeah, success is 0. Then we try to ping R2 from R4. So let's try to ping R4. Ping 192.168.3.2. So it's success actually. So in order to ping R4 from R1, we have to issue a command on R2 to see the OSPF database. So let's see. It's IP protocols. Here we will see that 192.161.202 ano 192.168.1.0 has no link. That's why from R1 we cannot ping R4. So we have to add the necessary configuration. So again, from R2 you have to configure network OSPF 1. Sorry. Router should be network 192.168.1.0. That is the missing one. 0 area 100. And end. Now let's try to ping R1 from R2. Now it's success. So this is a sample configuration of single area OSPF troubleshooting. Now I will show you sample configuration for the multi-area OSPF. This is we have done in the laboratory number 6. So here we need 4 routers for Cisco. We need the 1941. Sorry. Here we have to put okay, is it on? We need 4 routers. So this is the topology. Here I have to rename this as branch 2. Where is the branch? Okay, so now we have to connect them. Copper crossover. Here. Okay. Here we have to configure the routers as per this laboratory. So here it says Use an OSPF process ID of 10 on all routers. Okay. So I will show you the configuration. On core 1, okay, then we'll do the core 2. Let's do branch 1. Okay, let's do the branch 2. And the subnet is 255.192, switch on. Then 01 is 254. 254. Huh? Sorry, this is 101. 254. It's invalid. Okay. So it's taking time. Switch on. Alright, so we have done all the configuration of all the routers. Now we configure the core one first. Here, there some configuration needed to be done. We have to configure the router's ID. So router dash ID 1.1.1.1 network 1. We do also on core number 2, we do the same thing. So here we have to change the host name first. Route was PF1 and router dash ID will be 2.2.2.2. Network. Oh, no. 255.255.192 area 20. Okay. Branch 1, we have to change the host name also. We have to configure first. Branch 1. And the router ID also we have to configure. Has to be 1-1. Okay. Dash ID. Dash. We have to do the same with branch 2. Then we're almost done. OSPF1. So branch 2. Now we have to show the particles of core 1 and core 2. core 1, the command is sh IP protocols. And from core 2, we also see the same IP. So here we can see they have assigned in the correct IP address. So branch branch 222 is 110. Okay, and this is it for the sample configuration for the multi-area OSPF. Again, this is my video presentation for this project, and thank you so much for watching. Have a nice day.